All right, let's look at the TCP/IP model, and then we're really have covered the whole chapter. Because what little they have after that, I've actually talked about to you before, and I'll mention briefly as we go through this again on it. And throwing you some stuff that really don't explain it to you right there, so I'm not sure why they give you quite as much as they do right there, but they do, without going into detail, which we're going to talk about later. We talked about the OSI model the other day. 7 layers. I told you the little saying to use for it was that I told you of using programmers do not throw sausage pizza away. Was the one I suggested. I told you there's some others out there. I don't think your book actually gave you one. Did they or did they not? I don't think they gave you any saying for it on it, but that would be a way for you to remember what your layers of the model are. You will find on test, you need to know them by number also on it, because you're going to find on test and on certification tests that they ask you either layer 1 or could ask you about the physical layer or ask you which layer is layer 3. We talked about the bits, frames, packets, and segments, which is how your data appears on each of those layers. On those top 3 layers, it's just the whole chunk of data that's been sent. Does everybody follow on that? Then when you get to layer 4, it's split into segments, and all we've done is just broke it down into the sizes that we can actually send on that network. And they're numbered so when they get to the other end, they can be put back together and make the whole big chunk again for the top 3 layers. The segment is passed down to the network layer. There it will take that segment, doesn't do anything to the segment. The segment stays completely intact as it was and puts it inside a packet where it puts on their IP addresses, the size of it, and error checking, and a few other things we'll look at later in the book. It passes that packet down to the frame, which again does nothing to the packet, and the segment's still sitting inside the packet, and it encapsulates it into a frame. And then the frame, it adds on there the physical addresses or MAC addresses, and again some other little pieces of information, and passes it down to the physical layer, and the physical layer puts it onto your media. And when it sends it out, it actually sends it out just as a bit by bit basis. It doesn't send a whole frame at a time, it's sending one bit after another bit. Does everybody follow on that? So you're working with bits when you get down here. The other end, it goes through the same thing, just going back upward. All right, questions on the OSI model? All right, now I'm going to I guess I'll erase this one off. I wonder if this one works. It does. Okay. Or a different color. All right, let's talk about the TCP/IP model. Which is another model out there of how networking works. And that anybody that develops something with networking, that when they develop a networking system, they should have it working with one of these two, although these two work right there together. But we standardized on these two, and that they are compatible, but they're two different ways of looking at it. They date from the same time period. They're both from originally developed about 1980. Okay? This one was developed by the ISO people. This one was developed by the people that had done Linux, not Linux, but done Unix and stuff. So it's sort of, and the ones that had developed the internet in the first place. So this goes back to the DARPA and AT&T, okay? And the universities and stuff. But they are very compatible. This one, they only came up with 4 layers on. This one, they came up with 7 layers. So this one gets a little more detail in the top, but most of the stuff is going to match pretty closely. So this one has an application layer. It has a transport layer. It has an internet layer. And remember who I said developed it, that it was developed by DARPA and the people that created the internet. It was developed with the internet, so they've got an internet layer. And then it has a network layer. So there's only 4 layers to it. Now, this one, as far as a little saying to go with it, I really have not ever seen anything in books ever giving you anything to remember 4 layers. Apparently everybody figures you can remember 4 layers, but you can't remember 7 layers. But in any event, when I took the class you're taking, the teacher I had then, he had a little saying for it that had his name in it that he came up with. Well, that wouldn't do y'all any good because y'all don't know him. But it worked for us and for all of his students. So sitting there, I was going, there's got to be a way to remember this one other than knowing him. So I sat there and came up with one off of what he had said. And his little thing was, his name was Art Tucker, and he told us Art Tucker is nuts. Well, y'all don't know Art Tucker, so that one doesn't make any sense to you, but if you did, it would make sense to you. So I came up with instead, a teacher is nuts. And all of y'all have had some teacher along the way that fit into that. Hopefully you don't put me into that category, but you can, if that fits for you. Okay? And they give you some little thing to remember it by. Now, notice, it's going from the top down as opposed to where I told you about programmers do not throw sausage pizza away. It goes from bottom up, okay? Although you can find some out there that go from top down on this one too, but they never clicked in my head. So I can't tell you what they are. But that one clicked to me. This one clicked to me also, okay? And that when I was sitting there in class and that we were going, well, that was nice of him to tell us that one for us to remember it, but we're going, what are we going to tell our students? What little thing could we come up with as a little saying for you to remember it that would make sense to you? So a teacher is nuts is what we came up with. And it really is I came up with. And the others thought that was pretty good too, and he did too, because that played right along with what he had taught us anyway. Now, off of this one, it really relates very specifically to this one, except it's changed names in some cases. These 3 layers right here all match to that one layer. And as we study on through, you're going to discover there's very little, like in the book. They're going to basically cover all 3 layers of this in one chapter. And the book takes the present approach from here on through of being essentially a chapter or 2 on each layer. So, but they're going to throw these together into one thing. there's not that much stuff that really occurs right here, okay? There's significant things do occur there, but they're not that big of things after all to it. So TCP IP took the approach of this was all involved in just working back to the application. And if you think about what I had told you just a little bit ago about, reminded you on, about how the data looks, that's on these bottom layers. On the top layer, on these top 3 layers, the data all looks the same on those 3, and it's just the data. Okay? So here, they went and put that all as one layer. Okay? Transport layer is the transport layer on both sides. That's the easy one for you. Same thing happens, both sides, they both looked at it the same way. And called it the same thing. Because then, the next 2 layers, it gets confusing for you. Because the names have different meanings. Okay? But we call it network on this side, and it's internet over here. The network on this side does not correspond to network on this side. And that's a confusing one for you. This one took, what it was this one took a little bit more approach looking towards the physical side of networking, where this one was looking a little bit more towards the software side of networking as they created it. And so their terminology of this one versus that one is that this one's looking a little more in terms of physical. So on this side, TCP/IP called it internet. And I actually think they originally called it internet work. Okay? Over here, ISO likes to call the layer network. And it really is dealing with between networks, which is what this is saying, and where they said network because this is where we've got our routers which connect our networks together. Okay? So that's different networks all coming together. So internet work, or internet, which is actually the name now, is a better name in a lot of ways on it. Okay? It's also where we're using the IP addresses, which are the network addresses, which gives us both the network they're on plus the host within that network. So we really are working with how are the networks connecting together. Does everybody follow on that? So it's internet on TCP IP, or it's network over on OSI. These 2 layers, which are getting more into the physical part, because this one actually is split, if you remember I mentioned the other day, with the max half of it is actually physical and the LLC is the software side of it. That this is more getting totally into physical type things to it, and TCP/IP puts it all as one layer, which it calls network. And at that point, you're concerned with putting it onto your network. MAC addresses just pertain to just the machine and doesn't tell you anything else about the rest of the network. The other one is, I said your device you're going to be using on the data link layer is your switches. All your switch does is connects your devices together within your single network. Does everybody follow on that? The routers connect your networks together. So this is working within just your network, really. This one's more concerned with getting things from one network to another network. That information's used there. Because when we pass things through you're going to find when you first do it, as it goes out, it goes all the way down, all 7 layers or all 4 layers. Goes out and goes across the network, but it's going router to router to router. Well, each router's got to look at it and see what the IP address is on it to send it on to the next place. Now that's not disassembling the packet, but it's just looking in the packet. Does everybody follow on that? So you're just looking on that. So it's coming back up to here, it looks at it, and then passes it back down to send it to the next location. But it didn't change anything in the packet. It did change the frame. It gets a new frame to it with new addresses. Because that MAC address is what device is it going from at that point, and what's the next device it's going to. This, with the IP addresses, tells you where did it originally start out from, and where is it ultimately going to. Y'all follow the difference on the two of those? So if we decide we want to take a trip to San Diego, they got a neat computer museum out there, at least I assume it's still there. And that we're going to take a trip out there and go see that tomorrow. Okay? We're leaving from Ringgold to San Diego. Because y'all all did bring a change of clothes to change it to tomorrow, right? And you got the credit card for just put gas in the cars along the way, right? So our IP addresses is we're leaving from Ringgold and we're going to San Diego. Now, how do we get to San Diego from here? Nowadays, what would we do? We'll put it in the GPS and take off and go, right? Or you'll put it in Google and we'll take off and go. Using Google as our GPS. So either way, it's the GPS. Okay? But more than likely, we know to get to San Diego, they're going to have to go to Chattanooga, right? And we can go up to Chattanooga and ask somebody there, how do we get to San Diego? And they may look at us and go, I don't know exactly how you get all the way to San Diego, but Memphis is on the way. So they ship us off to Memphis. Okay? Or ship us off to Nashville, actually. Either one will work. They get us to Nashville. Or get us to Memphis. When we get to Memphis, we ask some people there, how do we get to San Diego? And they look at us and go, well, the road does go there, I'm pretty sure, but I haven't ever been there, but I know it's going on westward. Just stay on 40 till you get to Little Rock, Arkansas. And so we set on out again, but at that point, what do we know about our trip while we're standing there in Memphis, when we go to leave Memphis? We still know we originally left from Ringgold, and we still know we're trying to get to San Diego. Does everybody follow on that? But what is our immediate concern now? We're leaving from Memphis and going to Little Rock. That is our frame. Okay? From down here. Our packet still says we're going from Ringgold to San Diego, but now, at this point, all we're concerned about is to get from Memphis to Little Rock. Because in Little Rock, we're going to leave I-40 and get on I-30. Okay? I happen to have driven out there to San Diego before, so I can tell you how to get there. It's fairly simple. All we got to do is go up there, get on 24, go over to 40, take 40 till we get to 30, get on 30, take it till we get to Dallas and get on 20, and take that until somewhere out near El Paso and get on I-10, and just stay on I-10 till we land in San Diego. And if y'all go pull it up, you'll see that's the route from here to there. But we keep changing every time we stop along the way, and it may be There may be ones that just don't want to drive straight through out there. But in about 52 hours, if we drive straight through, we can be in San Diego. Or y'all could be ones that think we gotta drive only 8 hours, stop and spend the night, and then drive another 8 or 10 hours or whatever. When I was in college, we put 3 or 4 of us in a car and drove straight through to the Grand Canyon in San Diego. Made it a lot cheaper because we didn't have motel rooms along the way. And with 3 or 4 people in the car, everybody takes turns sleeping and driving. But there's your MAC addresses and your IP addresses. You'll see how the two work together though, and how it really similar, relates somewhat to real life. Post office is a better example because when you mail something there, they keep changing packet type things that they're putting it in as it goes on out there, but your original letter never gets changed. Okay? But they keep putting it into a cart or container or something to put it on the trucks to go to the next spot. That then takes it off, looks at it again, and then routes it on. And they never look inside your envelope. Y'all follow on that? So your address you send it to out there stays the same, but it's sitting there along with other stuff wrapped up, shipping on to the next spot, and keeps getting undone, looked at again. So the post office is a really good example, but a lot of people can picture where I just gave you the example of driving across the country. You can see that approach also to it, as far as seeing the difference in how you're looking as you go. Because you may have taken some trips. A lot of us have, where we've done somewhat similar to that we didn't know exactly how to get all the way to where we were going. We knew the road goes all the way there, but we went and visited with somebody or something for a little bit and then asked them how to get on to the next place, what's the best way to go on. Because the other part is Google doesn't always send you on the best route, okay, or your GPS. That sometimes there's another way that people know is a way to get around it, but those don't know it as being a really good, simple way. And then I think I told y'all where you gotta be careful with them too. Sometimes they send you off on a way you can't get there. But there's your 4 layers there. There's how they link back and forth. So the 4 and the 7 are not totally different things. Because when you first look at the 2 of them, your thought is, wait a minute, there's 2 totally different approaches. Well, it is a different approach, but they're still doing exactly the same thing, and they are very compatible. The other part is, if you notice right here, where we've got the big things, they've got their own layers, and here, where in here they sort of cross some layers some too. Because here we had the data. Here we had the segments. Here we had the packets. And we had the frames essentially down here, although we said it was bits down here as we put them out, but that related, okay? But really the unit we had was really frames down here on the bottom. But when you're looking at the 7 layers, really bits is what you're working with down here, okay? Whereas when you're working with 4 layers, you got the frames here, you got the packets here, the segments here, and the data here. So they've got it more precise to that. Likewise, the devices, this is passing back to your PC. Up here is what you're really concerned more about. It's how do you get to your PC? And I'm saying PC as a broad term right there. Whatever device it came from in the first place, okay? Be it your phone, your iPad, your PC, your server, whatever, okay? At this point, we're really just working in the networking stuff. This one we were working with the routers switches here, and the digger. Okay? Now, oh, and by the way, they said there was 4 machines didn't have Office in here, and they're all supposed to have Office on it. Every machine's supposed to have Office on it now, as they came up and fixed it that day. Or told me they fixed it, so I'm assuming they did. Because I filed a trouble ticket on it, and an hour or so later, Daniel wrote me back and said, it was either 3 or 4 machines that he said there was 3 or 4 machines that he found it wasn't on and that he put it on. Questions on that? That's going to be the course in a nutshell. Okay? Because from here on through the book, everything we're dealing with essentially is what I just put up here on the board. Okay? That we're going to spend time talking about the packets, talking about the frames and the segments, and we're going to spend time, which I didn't put right here, but we're going to talk about how the IP addresses work and how to set those up, because that you have control over. The MAC addresses on this layer, essentially, and in theory, you have absolutely no control of, okay? Because that's made in at time of manufacture. The MAC address has 12 hexadecimal characters to it. The first 6 makes up the name of the organization, and it's an organization name, and the last 6 is a serial number by the organization. It's burned in at time of manufacture. Now, it can be changed in some limited situations. Routers can change. You can change the MAC address on a router. Really, you're not really changing the MAC address. You're just making it appear to be a different MAC address. The original burned in one is still in there, but you can actually program around it, tell it, don't use that one, use this other one. And that will serve a couple of cases. The big one is that means router fails and you replace the router. You have a lot of things you set up within there on the switches that point back to the routers, and actually you can change it on the switch too. Although usually they just say about routers. That they point back to a specific MAC address on a router, and if you didn't have that ability, you'd have to go reprogram all of those, reconfigure them. If you can just set that router to be the same name as the old one that you just trashed, then you don't have to change anything else because everybody else thinks it's the same router that was sitting there. Likewise, in your home usage, you can actually change it on there too, so that you can get it to not have to be rechanged at the ISP office of what the address is, that it can keep on working without having to contact them. Although ISPs, my experience has been when it comes to trying to change a MAC address that they recognize, because a number of ISPs now use the MAC address as an indicator to know whether that is a paid up legitimate user, and that if that's not in their table of people that have paid and are supposed to be using them to connect to the internet, they just block that address. And my experience has been you can call them and get them to change it real quick. Although they will always tell you it will take up to 48 hours, my experience is within minutes it took effect. But if I was them, I would do like they do and tell you it may take up to 48 hours. And that way, if there's any little delay on it passing itself out to everything, they've covered themselves. But it really usually works real quickly. Other part is that sheet of paper we were printing out the other day has all of this summarized on it right there, written out a little neater than I ended up with it there on the board. If I had a little bit bigger board, I would have spread it out further for you. But this room does not have big boards. And y'all all, I think, got a copy of that printout the other day. I think one of you printed 6 copies and passed it out to everybody. Right? So use that as a study source for the test. Keep it as you go on through, because it's going to have things to relate back as we talk about those specifically as we go on through the course. Questions on all of that? So encapsulation has been an important term we've covered through the book, through the chapter. So we've talked about that, of where you encapsulate packets into frames or segments into packets. Decapsulation is where you tear them apart. So they throw you some about that again there at the end. They mentioned about segmentation, which I've already told you about. And all you're doing when you make your segments, you're segmenting the data, but what you're doing is you're just breaking it into smaller, usable pieces. Okay? Is all you're doing at that point. That's sort of like if I took y'all all to lunch today and took you to some expensive steakhouse and they set a big steak down in front of you. You're going to segment that steak before you go to eat it. At least I hope you all are, or that you're going to embarrass me and I'm going to tell them, no, I've never seen that person before and he promised to pay for the whole lunch. Whereas you're going to sit there and cut it into smaller pieces to eat it, but you're going to eat the whole steak, right? But you can't eat the whole thing as one big chunk to start with. Agreed? Now, agreed, if we go to KFC to get something, the Colonel would tell us just to eat it with our fingers and pick up and grab and eat the whole thing. But if I've taken you to a fancy steakhouse, that's not what you're going to do there. You're going to break it into smaller pieces to eat it, correct? So that's all segmentation is make it the size that it will fit onto that network. But when we cut that steak up, the size he cuts the pieces to eat on it and the size I cut to eat, because the size I might be able to get in my mouth, since I was at the dentist last week and I've still got a little sore on it, might not be as big of a piece as he can put in his mouth and eat. Does that make sense to everybody? So his segment is a larger segment than my segment. And he may just think steak is best eaten in thin little, real thin slices on it. So he may be slicing it off in really thin little pieces. Now they all think you're weird. I don't know what, he may really pick it up and just eat it. Okay? But y'all follow on what segmentation is. It's getting it into a usable size there. Okay? And so that's common out there. Sometimes if you go to put something in your car, we got to segment it before we put it in your car, because we can't put that big of a thing in your car, but we can take it apart and put it in there. Okay? We segment it. And when we get wherever you're going in the car, when you take it out, you put it back together and it's all there. Protocol data units, that is just what these segments, packets, and frames are. Is their PDUs. So you'll see them as protocol data units. Is what the book is calling them, which I like that name. But you will find in some other books that instead of it being a protocol data unit, it will be a packet data unit, which gets confusing. Because packets are a packet data unit, frames are a packet data unit. Protocol data unit keeps that confusion out of there. But do be aware that can be the definition of PDU also. Okay? So they tell you on that one, I've talked to you about the addresses already, so you know all about that at this point. They tell you a little bit. There is always on those addresses, you put 2 addresses on there, which is what I kept telling you, but it didn't specifically say that. Because you've got a source address and a destination address. The source one's where it's coming from, destination's where it's going to. And that applies both on the physical or MAC addresses and the IP or logical addresses. Okay? You have both a source and a destination. And then they give you a little bit of picture of that. On the logical or network or IP address, it's got part of it we'll see is what network does it belong on, and part of it is what is its actual host number on that network. MAC addresses have what was the organization that created it, and then basically a serial number within that organization, which gives it a totally unique address nowhere else used on the whole internet, on any other network device. Although sometimes they do goof up, and that presents problems. And that there is chapter 3. Questions on it. Now, that doesn't mean we're not going to have class on Thursday. We're going to go ahead and start into chapter 4 and get going on that, because actually they're talking about the cabling at this point on it. And if we get ahead of it right here, there's a good bit of stuff right there in the chapter. But between the next two chapters, somewhere in there, I'm going to have y'all build cables. Okay? So, actually, we may do that on Thursday. I'm going to show you how to make the plugs for the cables. Since we're a little bit ahead right here, that'll give us some leeway there. And get going on that. Any questions on that? But in the meantime, that'll let you out about an hour early today. Unless y'all want to protest that one, and then I can come on up with something and we can talk on about today. The looks I just got on that one, that didn't go over at all. And I can go back down to the office and start grading on some of y'all's stuff, because yes, I am behind on getting grading done. But it's trying to stay caught up just on your assignments and grading your discussions. Your discussions are all graded, but that's the one the schools put as the most critical thing of what we're doing. Okay? That's what they're grading me on. And that every 3 weeks they check all of us online instructors for that. Now, y'all don't have discussion in here, but those of you that got me 2601 know that yes, I've been posting them out there, and that it appeared again last night for you on time. Your tests should be all working, although I just saw an email just before I walked down here, because I didn't check email very well this weekend because I didn't have a PC with internet. And when I said PC, on that laptop or PC, usually when I'm on the road it's on my laptop, and trying to do Blackboard and on your phone is not real good. If any of y'all have tried that, it doesn't work real good, but it did do it. So I was real limited on doing that. And then email for me, if I use it here at school, it looks different than when I look at it at home. It stacks messages together, so that if all of y'all responded to an email I sent you and just hit a reply back, it shows up as one reply back, and I have to look in there and notice that there are other replies underneath of it when I opened that one, and catch the fact there was some others. So sometimes I'll overlook somebody's email because I didn't notice and think about it as I was opening the email to notice that there were others beneath it. And usually I'm used to it just being, you see the replies or whatever, they're both older parts. Well, it's anything else that had the same message heading on it. They all put, Outlook puts them all in the same place when using it on the web. Here at school, it's got almost totally separate messages, so it's easy. So I'm discovering this morning that I overlooked a few people's emails accidentally, but particularly when I'm sitting there trying to look at it on the phone, I have that problem. I have it some on the laptop PC, but I have much more of a problem on the phone because I don't at all notice. Because on the PC, when I open, I'm seeing that it's got some other stuff sitting there. more easily, but on the phone, I don't see that at all unless I specifically go and scroll down looking. Well, I don't feel like doing that on every email. I just don't think about it because I get a bunch of emails in every day. And my personal email, which is through Yahoo, actually, it's an AT&T account, but Yahoo is the one running it. Sort of like school's email is run by Microsoft. It keeps everything separate for me. So I can mess up sometimes on the school. And I can't find a setting that will allow me to say, don't stack these things. There may be a setting out there for it, but I haven't found it yet. If I can, I'm going to tell it to quit stacking them. And I know what it's doing. It thinks it improves it because you don't see as much stuff sitting there. That it's just telling you the major things, but it doesn't show very well to the other for me to catch that there's more stuff down there. And then if I have replied to some, I have to be careful trying to figure out which ones I replied to, which ones I didn't. So on the weekends, if you send me an email and then you get 3 different responses back that basically all say the same thing, it's because I didn't notice that there was a reply sitting there underneath it because it didn't show the reply as easily to me, and I may have seen it a couple of times. I try to go ahead and move them over into the folder where I put them into after that. But then if somebody else sends that same one, it's stackable again. If I do look down, I may not notice I actually did reply to yours before. All right, any questions? Y'all get the whole idea of Chapter 4, which the test is not due till next Monday. So you still got a week on it, but you can go ahead and take it. And you do get 2 chances at it here in Cisco. Those of you in 2601, tough luck. You only get 1 shot. And then I've got to start transferring grades also, and I've got to get that finished, put in all the permission forms. And I think I've got all of y'all's, if I remember right. I really haven't looked and I haven't put them in out there. And once I stick those in, maybe I can get that done right after I go get lunch. And then if there's somebody I don't have, I'll send a note and say, you need to get it to me. Or if somebody else is listening to this later, because I will post it in the 2 online classes. And if you notice, the Chapter 2 lectures appeared out there last night. I know that's a little late on them. And that the Chapter 3 ones, except for the Chapter 3 Part 2 from WCC, but y'all's was there. So I think I covered everything in Chapter 4, y'all. Yeah. Actually, it was the WCC Part 1, or no, it was y'all's Part 2, because the other campus only met once last week. I met y'all twice last week. So they got a long lecture that I tried to cover everything in one day that y'all got in 2 days. And hopefully I can get this one put out tonight, but it does. My machine's got slowed down at home for some reason, and it's taking extra long to produce the video version of the audio files. Although uploading to YouTube just took a few minutes last night. That was quick and simple. It always takes a little longer to produce the file anyway, but my machine was just dragging on some stuff last night for some reason. And my connection speed was still really good. That Comcast says I've got 80, but it clocked in at 93 last night for the download. Now my upload speed's not real good because it's only 5, but that works. I thought it was better than that, but last night it was only at 5, and I thought I had been clocking better than that. I don't know what's going on with that. But it uploaded real quickly to YouTube anyway, so maybe the tester just didn't know what it was doing. All right.